It's gray dawn. The alarm has been dismissed twice. The body is still under the duvet, and the ceiling is doing what ceilings do. The story everyone tells about this moment is sadness. The story neuroscience has quietly rewritten over the last decade is that this is a brain that has stopped expecting reward to follow effort. For 60 years, we called this a chemical imbalance. The newest research says we were looking at the wrong system. The chemical imbalance story has a date of birth. Joseph Schildkraut in 1965 published the catecholamine hypothesis of affective disorders in the American Journal of Psychiatry. The reasoning was honest but indirect. Drugs that boosted certain neurotransmitters seemed to lift mood, so the disorder, the thinking went, must be a deficit of those neurotransmitters. The theory was reverse-engineered from the medicine, not measured in the brain. And the medicine, in the 1980s and 90s, became a product. The serotonin variant of the story, that depression is what happens when you don't have enough serotonin, was easier to draw on a pharmaceutical ad than the truth, and it traveled further than any peer-reviewed result behind it. In 2022, Joanna Moncrieff and colleagues at University College London published a systematic umbrella review in molecular psychiatry. They aggregated decades of research across serotonin metabolites, receptor density, transporter studies, and depletion experiments. Their conclusion was unusually blunt for a journal of that caliber. There is no consistent evidence that depression is caused by a deficiency of serotonin. The medication may still help some people, but not for the reason the story said. The lay public had absorbed a model that was scaffolding, not biology, and the cost of that model wasn't only intellectual. If you were told your sadness was a missing nutrient, then the moment the missing nutrient didn't help, the implication landed on you. You weren't even broken in the right way. The map was wrong. The territory was bigger. Here's the frame that's quietly replacing it. Carl Friston, in 2010, in Nature Reviews Neuroscience, articulated the free energy principle, the idea that the brain is constantly minimizing prediction error. Everything it does, from perception to movement to mood, can be understood as the management of a forecast about the next moment. Lisa Feldman Barrett and W. Kyle Simmons, in a 2015 paper in Nature Reviews Neuroscience, took that frame and turned it inward. They argued that the brain isn't just predicting what's out there. It's predicting what's in here: heart rate, gut tension, energy reserves, inflammation. The technical word is interoception, and the consequence is enormous. Mood, in this view, is not a feeling about the world. It's the brain's forecast about whether the body's resources can meet the world's demands. Then Stephan and colleagues in 2016 in Lancet Psychiatry fitted depression directly into that frame. They described it as allostatic dysregulation, a state in which the brain's prediction of future effort and reward has flattened or inverted. Whatever you do, the model says, won't be worth the energy it will cost, so motivation stops, movement stops, effort stops. From the inside, it feels like there's no point. From the model's perspective, you are obeying a forecast that has stopped believing the future will pay you back. Depression isn't low mood. It's an energy budget drawn by a brain that has stopped expecting the outside world to refund the deposit. And the prediction is being fed by data the head alone can't override. Charles Raison and Andrew Miller, in 2011, in Current Psychiatry Reports, gathered a body of work showing what clinicians had been seeing for decades, that systemic inflammation tracks with depressive symptoms in ways that don't fit the serotonin story at all. Patients given interferon for hepatitis treatment, which spikes inflammatory cytokines, frequently developed full-blown depressive episodes. People with chronic inflammatory conditions had depression rates several times the baseline. Something in the immune system was talking to the mood circuit, in a voice the old model wasn't equipped to hear. Jennifer Felger, in a 2019 review in Pharmacology and Therapeutics, showed the mechanism more precisely. Peripheral inflammation, signaled to the brain via cytokines and the vagus nerve, suppresses dopamine release in the basal ganglia. The exact circuit responsible for motivation and reward goes quiet, not because the chemistry is missing, but because the body's surveillance system has decided this is not the moment to spend energy on the future. The result on a screen looks like depression. From inside the body, it feels like depression. It is depression. Ole Kerhler-Forsberg and colleagues, in a 2019 meta-analysis in Acta Psychiatrica Scandinavica, showed that anti-inflammatory adjuncts produced measurable benefits in a subset of patients, particularly those whose blood markers actually showed elevated inflammation. Not everyone, not as a slogan, but enough to confirm the chain. The mood you couldn't shake was, in some cases, an immune system in the wrong key. The medicine that argued only with serotonin was sometimes arguing with the wrong organ. And this is where the well-meaning advice gets dangerous. The STAR*D trial, led by A. John Rush and published in 2006 in the American Journal of Psychiatry, followed thousands of patients through real-world antidepressant treatment. The first-step remission rate, patients who fully recovered on the first medication, was roughly 1 in 3. By the fourth step, the cumulative remission rate was around 67%, leaving a substantial group whom the standard model couldn't reach at all. These are not lazy patients. These are the ones the chemical imbalance map fails on first contact. So what does the surrounding culture tell them? Try harder. Think differently. Be positive. Daniel Wegner in 1994 in Psychological Review gave us the ironic process theory. The deliberate attempt not to think a thing makes the thing more available, not less. Tell yourself not to feel hopeless, and you've just rehearsed hopelessness once more, with a louder voice. Joanne Wood and colleagues in 2009 in Psychological Science ran a study that should have ended the affirmation industry. They asked low self-esteem subjects to repeat the affirmation, "I am a lovable person," several times. Mood went down. Self-esteem went down. The affirmation collided with the listener's actual prediction model and lost. So the brain treated the affirmation as evidence of how far the speaker was from the claim. In the predictive frame, this is obvious. Forcing a positive prediction that the brain cannot connect to lived data doesn't close the prediction error. It widens it. The model logs the optimism as noise. The depression hardens. The well-meaning advice becomes mechanically anti-medicine. Okay, so what does work? The honest answer is that several different things do, and they work for reasons that finally line up with the predictive frame. First, behavioral activation. The lineage runs from Peter Lewinsohn in the 1970s to Sona Demidzian and colleagues in 2006 in the Journal of Consulting and Clinical Psychology, where a randomized trial showed behavioral activation matching cognitive therapy and outperforming antidepressant medication for severely depressed patients. The instruction is almost boringly concrete. Schedule small, specific, low-risk actions and let mood lag behind action. The mechanism in predictive language is that you give the model a series of tiny forecasts it can quickly confirm. The bed got made. The walk happened. The friend was called. Each completion is a small piece of evidence that the future is not, in fact, a vacuum that swallows effort. The model updates from the bottom. Second, rapid-acting antidepressants that bypass the monoamine system. Robert Berman and colleagues in 2000 in Biological Psychiatry showed that a single subanesthetic dose of ketamine produced significant antidepressant effects within hours, not weeks. John Crystal and colleagues in 2019 in Cell described why this was a paradigm shift. By acting on NMDA glutamate receptors and triggering rapid synaptic plasticity, ketamine appears to reset the prediction substrate, opening a window in which the brain can learn a new forecast. Third, sleep, light, and movement. Matthew Walker, in his 2017 book Why We Sleep, gathered the evidence that sleep loss is one of the most reliable amplifiers of depressive symptoms and one of the easiest predictors to correct. Predictive coding doesn't work on a brain that's been denied the offline period it uses to consolidate yesterday's data. And finally, therapy, when it updates predictions rather than just rearranging thoughts. The cognitive behavioral lineage from Aaron Beck onward has always implicitly been a prediction correction enterprise. Done well. It works. You don't argue with depression. You feed the model evidence it can no longer ignore. The serotonin story let us treat depression as a missing nutrient. It was kind in the short run. It was wrong in a way that left a lot of people stranded when the nutrient didn't show. The predictive brain story is harder because it asks the body and the schedule and the inflammation and the past all to count as part of the diagnosis. It's also more hopeful in a particular way. Forecasts can be retrained, and the brain is built to do exactly that whenever the evidence reaches it. So if you're in this somewhere, the question isn't what's broken in my chemistry. The question is, what does my brain currently expect, and what is the smallest piece of evidence I can hand it today that contradicts that expectation? Not an affirmation, evidence, a walk, a call, a meal, a scheduled hour of light. The model updates from the bottom. It always has. If this gave you a frame that fits better than the one you've been carrying, send it to someone who's been told their problem is a missing chemical, and I'll see you in the next one.